Picture this. It's a hot summer night, the kind where the air is thick and heavy, the AC hums, working tirelessly to keep you cool and comfortable. Your fridge keeps drinks cold, a refreshing escape from the heat. And you're streaming your favorite show, lost in another world. Suddenly click, darkness descends, silence fills the air, no Wi-Fi, no connection to the outside world. In that instant, you realize just how much we depend on electricity for our modern lives. Without it, our world grinds to a halt, and we are back to the Stone Age. Food spoils quickly, communication fails, leaving us isolated, and even the simple act of getting water might become impossible. This isn't magic or some futuristic technology, it's the power grid, the unsung hero of our daily routines. A vast, interconnected system stretching across continents that silently and efficiently keeps our lives running smoothly. We flip a switch and expect instant light without a second thought, but behind that simple action lies a marvel of engineering and complex logistics. The electricity you use was likely generated hundreds of miles away just seconds ago, a testament to the speed of modern energy delivery, and traveled an incredible journey through a web of wires to reach you. Hospitals where lives depend on uninterrupted power, traffic lights, ensuring the safe flow of vehicles, data centers, the backbone of the internet, and countless businesses all rely on this steady and reliable flow of electricity. That reliability is no accident or stroke of luck. It's the result of meticulous design, constant monitoring, and unwavering vigilance by thousands of dedicated engineers. Next time you flick a switch and the lights come on, remember the vast, invisible network working tirelessly to make it possible. This is more than just wires and poles stretching across the landscape. It's the very backbone of modern civilization, supporting our way of life. Understanding how it works, its complexities and challenges, helps us appreciate and ultimately improve this incredible marvel for the future generations. Ready to explore the fascinating journey of electricity from its source to your home? Let's dive in and unravel the mysteries of the grid. The story begins with the grid itself, a complex and vital network. The power grid is one of humanity's largest, most complex machines, a vast network of power plants, wires, and control centers. In North America, there are 4 major grids, each operating like a synchronized machine to keep millions powered. The grid connects where electricity is made, often far from cities, to where it's used almost instantly. Multiple companies feed power into the grid, and utilities draw from it, making the system reliable and flexible. If one plant goes down, others pick up the slack, preventing blackouts. Now let's follow the path of electricity from its source to your home. Electricity's journey starts at a power plant, the origin point of the power that lights up our lives. Power plants can be fueled by coal, gas, or nuclear energy, each harnessing different resources to create electricity. Renewable sources like hydro, utilizing the force of water, or wind, capturing the breeze, also play a vital role. Regardless of the source, they all share a common method, using turbines to generate power. These turbines are the heart of the electricity generation process. Most generation involves spinning a generator, a crucial step in converting mechanical energy into electrical energy. This turning motion is ingeniously transformed into electrical current, the lifeblood of our modern world. To efficiently send electricity long distances, often across vast landscapes, it's sent through a step-up transformer, boosting the voltage to incredible levels. This raising the voltage is essential to minimize energy loss during transmission, ensuring more power reaches its destination. High-voltage lines then carry it across the landscape, a network of power weaving through our environment. Eventually, it arrives to substations strategically located near cities. At the substation, the voltage needs to be adjusted again. A step-down transformer lowers the voltage to safer levels, preparing it for local distribution. The power is then distributed through smaller lines, branching out like veins to reach individual homes and businesses. These lines weave their way to neighborhoods, bringing electricity closer to where it's needed. Near your home, the final stage of voltage transformation occurs. A final transformer steps the voltage down to what your appliances need, ensuring safe and efficient operation. The wire then runs into your house, connecting you to the vast electrical grid. It passes through your breaker panel, the safety hub that protects your home from electrical overloads, and finally to your outlet, ready to power your devices. All of this intricate process happens in the blink of an eye, a testament to the efficiency of our electrical grid. But what kind of electricity is flowing through those wires, and how does it actually work? Electricity, the lifeblood of our modern world, comes in different forms. There are two primary types of electricity that power our lives: direct current, DC, and alternating current, AC. Each has unique properties and applications. DC flows steadily in one direction, like from a battery, providing a constant and stable source of power. AC, the type used in our power grid, wiggles or oscillates back and forth, typically 60 times per second in North America. So, why AC for the grid? Because transformers, essential devices for efficiently changing voltage levels, only work effectively with AC. This crucial ability lets us send power over long distances with minimal loss, making it incredibly efficient, then step it down to safer voltages for use in our homes and businesses. Back in the early days of electricity, Thomas Edison championed DC, while Nikola Tesla passionately advocated for AC. Ultimately, AC prevailed, largely because of its invaluable partnership with transformers. The entire grid pulses in perfect synchronization at 60 Hz, seamlessly connecting millions of devices and people in a silent, reliable, and constant rhythm. In fact, even electric clocks once relied on this precise frequency to keep accurate time. AC is truly the unsung hero, quietly making our modern electrical world possible and powering our daily lives. But there's far more to the grid than simply moving electricity from one place to another. Electricity can't be stored in large amounts. It must be generated the instant it's used. The grid is a real-time marketplace, balancing supply and demand every second. Grid operators act like air traffic controllers, predicting demand and dispatching power from different sources. Baseload plants provide steady power. Peaking plants kick in when demand spikes. This constant balancing act keeps our lights on and our world running. It's a high-stakes 24/7 performance. But how do we ensure the power is always high quality and reliable? The grid is built on three goals: quality, reliability, and balance. Power quality means stable voltage and frequency, crucial for sensitive electronics. Reliability comes from redundancy. If one part fails, others take over. Operators constantly balance supply and demand, using the cheapest sources first, but keeping fast-acting plants ready. These goals are interconnected. A failure in one can cause blackouts. Every decision is a careful calculation to keep the grid running smoothly. It's a dynamic, living system. Now the grid faces new challenges and opportunities. The grid is changing fast thanks to renewables like wind and solar. These sources are clean but variable. We can't control when the sun shines or wind blows. Operators need agile backup sources like batteries or fast-start gas plants to fill gaps. Distributed energy, like rooftop solar and electric vehicles, turns the grid into a two-way street. This decentralization boosts resilience but adds complexity. Smarter infrastructure and better forecasting are essential to manage this dynamic new reality. The challenge: integrate renewables while maintaining quality and reliability. It's a time of innovation and transformation. Enter the era of the smart grid. The smart grid is the next evolution, making our power system intelligent, responsive, and efficient. It uses sensors, smart meters, and data analytics to give operators and consumers real-time information. Outages can be pinpointed and fixed faster. Renewables are integrated more smoothly. Smart meters help you save money and energy. Large batteries and electric vehicles can store and supply power, stabilizing the grid. The smart grid moves us from centralized control to flexible, data-driven coordination. This is where future engineers and scientists come in. Reinventing the grid is a monumental challenge and a huge opportunity. Get curious, ask questions, and imagine your role in building a sustainable future. If you are not already following, consider subscribing to stay on top of what is yet to come.